Hi, welcome back to Mastering C++ Unlocked. In today's lecture, we will explore loops in C++, a fundamental concept for every aspiring programmer. For loops, while loops, do-while loops, nested loops. Let's dive in and get started. Introduction to loops. A loop is a control structure for repeating a block of code until a condition is met. Automate repetitive tasks and reduce code duplication. A loop executes the same block of code multiple times based on a condition. For example, printing number from 1 to 100 without a loop would require 100 lines of code. With loops, just a few lines, improving efficiency and readability. Why use loops? Loops handles tasks like processing customer data or iterating through datasets efficiently. They enable dynamic programming, especially in scenario involved repeating calculation or user inputs. Types of loops in C++. Loops are used to execute block of code repeatedly based on condition to reduce redundancy and improve code readability and efficiency. For loop, use for known iteration, iterating over arrays. Ideal for fixed iteration with known start and end points. While loops, use while for unknown repetition, reading input until valid repeats as long as condition is true. Do while Use do while for mandatory execution. Menu-driven programs execute at least once before checking the condition. Nested loops inside loops for complex operations. For loop non-iteration. The for loop is a fundamental concept in a programming used to automate repetitive tasks. The for loop is best suited for scenarios where you know the exact number of iterations ahead of time. It combines initialization, condition, and update is one compact line, making it efficient for predictable tasks. For example, iterate through an array which is a fixed size is a perfect use case for a loop. The for loop is ideal for cases where the number of iterations is fixed or predetermined. A for loop works like a planned journey. You know where it starts, where it ends, and how many steps it takes to get there. It is a concise and efficient for tasks within a defined range of repetition. Combine initialization, condition, and update in a single statement, making it concise and easy to read. The for loop brings together all three components of a loop: starting point, condition check, and update in one statement, which make is highly organized. Initialization, condition, and increment are decrement. Initialization set the initial point for loop variable. The initialization set the initial value of the loop control variable, like int I equal to 0. This is executed only once at the start. Initialization defines the loop variable which track the number of iteration. In this example, I is start at 1. Condition determine if the loop should continue running. The condition is checked before each iteration. If the condition evaluates to false, the loop terminates. If the condition evaluates to true, the loop continues. Once it becomes false, the loop exits. Increment or decrement. Update the loop variable after each iteration. The increment decrement modifies the loop variable after each iteration, preparing it for the next cycle. Each of these components play a critical role in controlling the flow and termination of the loop. Okay, so for initialization A1, I equal or less than 5, and then one is increment. Initialization, the loop control variable is 1 to set. Condition is the loop runs while I is less than or equal to 5. And increment is after each iteration 1 is incremented by 1. And cout iteration, I output the current iteration number 1 followed by a new line, and return 0 indicates successful program execution and terminate the program. So answer will be iteration 1, 2, 3, 4, 5. Okay, another program. Int I, the loop start with I of 0, and then the loop execute while I is less than or equal to 10, and then the value of I is increased by 2 after every iteration. So what would be the answer? The answer would be the output display even number from 0 to 10. And another program, initialize the loop begin I to 5, and the loop begin while I is greater than or 0. The value I is decreased by 1 after each iteration. So what would be the output? The output displays number from 5 down to 1. Nested for loop. A loop inside another loop used for multi-dimensional tasks. Nested loops are essential for solving multi-dimensional problems. In the example below, the outer loops I track rows and the inner loops J track columns. This structure is useful for tasks like matrix multiplication or creating graphical patterns. First, outer loop I is set to 1, and then I is executed as long as I is equal to or less than 3, and increment by 1 after each iteration. And this one is inner loop J is set for 1, the value is 1, and then while J is less than or equal to 3, this one, and then increase J by 1 increment after each iteration. The inner loop executes 3 times for each value of I. Output the pair I and J followed by a space, and count cout and I'll add a new line after the inner loop finishes execution for each I. So do you have idea what would be the answer? Yes, this one. And now let me know what would be the answer of this one. Yes. And now you tell me what is the difference between this one and this one, where the both codes are very similar. There is another example. The line declare an integer variable of sum initialized is 0. The variable will be used to store the cumulative sum of numbers for 1 to 5. Initialization is 1 to I, and the create a loop counter variable I and initialize it to. Condition 1 less than or equal to 5, the loop runs as long as I is less than or equal to 5. When this is actually 5 times for 1, I is equal to 1, 2, 3, 4, and 5. This line outputs the string sum followed by the final values to the console. The operator is used for concatenate strings and variable for output. And I'll move to the cursor for new lines, and for example, if the sum is 15, output will be 15. Hands-on practice, write a for loop to calculate the sum of the first 10 even numbers. We have 5 minutes 10 minutes. Okay, you can take 10 minutes to 15 minutes to solve it, but obviously it will take too much time, so I'm placing the code here, this one. So int sum, a variable 0 named sum of type integer is declared and initialized to 0. This variable will be used to store the cumulative sum of even numbers. Initialization to 0 ensure that there is no leftover value for previous operations. For int 2 and I less than 20 and I increment for 2, this is the start of a loop that iterate through even number from 2 to 20. Integer I is equal to 2. The loop control a variable I is declared and initialized to 2. So this one is 2. The first even number in the range 3 I less than or equal to, the condition checked whether is I is less than or equal to 20. If true, the loop continues. If false, the loop terminate. And I plus equal to 2. After each iteration, the value of I is incremented by 2, ensuring that the only even numbers are proceed, like 2, 4, 6, 20. And sum plus 1 equal to I, this is a shorthand for sum is equal to sum plus 1. The current value of I is added to sum and the result is stored back in sum. For example, the first iteration I is equal to 0, 2, so sum equal to 0 plus 2 equal to 2. And in the second iteration, I equal to 4, so sum is equal to 2 plus 4 equal to 6, and this process repeat until the loop ends. And then see out sum and sum endl. The count statement output the final value of sum to the console. The sum, this is the next string that labels the output. The sum display the value stored in the sum variable, and endl adds a new line character, moving the cursor to the next line in the console for better readability. So answer would be 110. The while loop, it repeats as long as condition is true. Initialize the variable. Initialize the variable and check the condition before the block. Update the loop variable to avoid infinite loop. Real world analogy, think of parking garage counting cars until it is full. And output would be 1, 2, 3, 4, 5. The do while loops guarantees that the code execute at least once even if the condition is initially false. Do code block to execute and while condition, and then int num do while and enter a positive number and see in num. So execute block, we see the execute block inside the execute first, and that is 1, and condition block, this one is a condition block, and check after execution the num is less than or equal to 0, this one, and repetition. If the condition is true, the loop runs again, otherwise it stops. This is especially useful for the scenario like a vending machine. Ensure you see the product menu at least once, even if you don't select an item. So further menu-driven programs display option to users and user input validation prompting until a valid value is entered. So do while loop, graphical representation. Nested loop, a loop inside another loop used for multi-dimensional data processing, for metrics and grids or generating pattern, etc. Outer loop, This one is outer loop, typically control for rows or primary dimensions. Inner loop manage the manage the secondary dimensions, completing its execution for every outer loop iteration, and then code block to execute. Another example, outer loop for int row1, row less than or equal to 5, row plus plus increments, execute 5 times, controlling the rows or primary dimensions. Inner loop, this one is inner loop for the columns. For int column equal to 1 and column less than or equal to 5 and column increments plus plus, runs completely for each iteration of the outer loops, controlling the columns or secondary dimensions. And then we have a code block execution, see rows and column, print each pair row or column to represent grid positions. This code will output all combination of row and columns where both rows and column range from 1 to 5. And here's it look like. Nested loop graphical representation. Key benefits of nested loops: similarity, simplicity. Nested loops break down multi-dimensional problem into smaller tasks. For example, in matrix operation, a nested loop allows you to iterate through rows and column efficiently. Condense multi-dimensional processing into structure blocks, making complex tasks more manageable. Versatility. Nested loops are versatile for working with data structure involving multiple dimensions such as 2D arrays or game board. For example, in a board game, nested loops check each cell in a grid for valid moves. Applies to scenario like image processing, board games, or data visualization. Real life analogy. Think of nested loops as managing a seating chart where rows represent section and column represent seats. Imagine a theater where with multiple rows and seats in each row. A nested loops help check each seat within a specific row, simplify the process of managing complex data structure. Common pitfalls: performance. Excessive nesting increase computational complexity, especially for large data set. Nested loops can lead to inefficient algorithm, especially when the time complexity become quadric or cubic. Use them judiciously for large data set to avoid performance issues. Indexing. Incorrect indexing errors can occur when the loop variable are not correctly assigned. Ensure each loop's index is used properly within its scope to avoid out of bounds or incorrect data access. Mixing up index can produce incorrect result or runtime errors. Overlapping scopes. Reusing loops variable can lead to unattended behavior. Reusing of the same variable for both outer and inner loops can overwrite values and cause error. Use distinct variable names for each loop to prevent such issues. A break statement. Exit the loop immediately, skipping all remaining iteration. For int I5 or I less than 15 and I increment, for a loop initialized with the I00, the loop condition is 1 I less than 15 is checked before each iteration. If I is less than 15, the loop continue, otherwise it terminates. After each iteration, the increment operations increase the value I by 1. If I equal break inside the loop, if an if statement check if the value of I is equal to 10. If this condition is true, the break statement is executed, this one, which immediately terminate the loop, skipping all remaining iteration. and count adl. If I is not equal to 10, the line executes. The current value of I is printed to the console followed by a new line adl. Flow of execution: the loop starts with I equal to 0 and runs until 1 less than 15 or until a break is encountered. For each value from I from 0 to 9, the condition is false, so that the count statement executes printing I. When I is equal to 10, condition I become the true and the break statement terminates the loops. The loop terminates before 10 because of the break statement. Terminate a loop permanently when a specific condition is satisfied, such as locating a desired item in a list. This helps streamline scenario by avoiding unnecessary iteration once the condition has been fulfilled. Continue statement. So, and for loop is initialized with I 0. The loop condition is I less than 16. Check before each iteration. If I is less than 16, the loop continues, otherwise it terminates. After each iteration, the increment operation I plus plus increase the value of I by 1. Then inside the loop, if statement, check if the current value of I is even. This is done using the modular operator, which calculates modular operator, this one operator, which calculates the remainder when I is divided by 2. And it continues. The continue statement skip the remaining code if the loop for the current iteration and move to the next iteration of the loop. If I is odd, the condition is false and the loop proceed to the next statement. And I equal to endl. If the condition is false, I is odd, this line executes. The current value of I is printed on the console followed by the new line adl. Only the odd value if I are printed because the continue statement skip the count statement for even values of I, allowing skipping specific iteration in a loop to avoid processing irrelevant data, ensuring the loop continues with the next iteration seamlessly. And this would be the answer of continue statement. Continue statement, graphical representation of continue and break statements. Key benefits of break and continue: efficiency. Efficient code execution is critical, especially when working with a large data set or complex computation. For example, in a search operation, if the desired value is found, there is no need to check the remaining data. Using break terminate the loops immediately, saving time. Similarly, continue skips over irrelevant data, focusing only on what is necessary. Readability: code with clear logic is easier to debug and maintain instead of embedding multiple condition statement. Break and continue streamline the flow. For instance, skipping invalid data entries with continuous avoids cluttering the loop body with additional check, enhancing readability. Common use cases: searching in datasets, exit the loop when a target value is found using break, or skip irrelevant entries using continue. Skipping invalid inputs, avoid processing incorrect or incomplete data by skipping over it. Game logic: handle scenario like stopping a game when a win condition or timeout is met. In searching dataset, break is ideal for terminating a loop once a desired item is located, while continue skip irrelevant entries like null or invalid data. In data processing, imagine processing a list of user input where some entries are incomplete. Continue can help skip those entries, focusing on avoid valid data. In game logic, break can stop the loop when a win condition is met, such as a proper scoring a certain number of points, while continue can handle cases like ignoring invalid moves. Infinite loops in C++. Loops that run indefinitely due to missing condition update or conditions always evaluate to true. So int I is 1, the variable is initiated to I, this is the starting point of for the loop. The second one is the while loop is initiated with the condition is I equal to 10, the loop will continue executing as long as I is not equal to 10. See out the value of I inside the loop, the current value of I is printed to the console. And then instead of incrementing I to move toward the condition I not equal to 10, the code determine I by 1. This causes I to move further away from 10 with each iteration toward tens. Why the loop gets stuck? The condition not never be false because I is moving in the wrong direction. Decreasing instead of increasing toward. This logical error causes the loop to execute indefinitely. This program will keep printing decreasing value of I until it's manually terminated. Summary. Loops overview. Loops save time by automating tasks that would otherwise require manual repetition. Choosing the right loop while for unknown iteration. Do while ensure at least one execution and for known for countable iteration. Control statement exit loops early when a condition is met and continue skip the current iteration and continue with the next. So break allow you to exit loops early and continue skips unnecessary iteration, improving performance. Key concept recaps: loop simplify repetitive tasks and improve code efficiency. Nested loop handle complex data like grids, and control statement managing loop flaws with break and continue. Loops are essential for repetitive tasks. Use nested loop for multidimensional data and control flow with break and continue for better performance. So loop type while, do while and for, and these are graphical representations. References. Thank you.